Hi everyone, in this video we'll go over an implementation of TF-IDF in Python. We will use a small corpus for educational purposes to understand what this technique consists of. We first will implement from scratch and then we will use sklearn to do the same thing, and we're going to understand if there are some differences and how those differences occur. This corpus is a sample removed from the Reddit comments. So corpus 1 is actually a comment, and it had been already pre-processed, so the text processing had already been done. So that's why you will see like it have instead of it has, because we already did the lemmatization and we have a clean text here. We did not remove any stop words, but we did the pre-cleaning, like the text processing already. So let's say that the first comment is, amazing book. I think it have a great balance of drama and hope. It is a beautiful read. Indeed, it is a masterpiece and a book to be read because poetry have its own flow. The second one is, this will be great. I really want an e-reader, but love my physical books so much that I do not see the point of buying one because they have beautiful covers. But if I can enjoy some of the benefits of an e-reader on the go, then come home and pick up the physical copy, I will do it. So for this implementation, we will use the pandas, and that's it. And the sklearn, we're gonna use the feature extraction text, the TF-IDF Vectorize. TF-IDF Vectorizer, it's inside the sklearn package. It's a toolkit. So we will go over that a little bit later. First, we will implement from scratch. So we will create a list of words from the first comment, corpus 1. We will just like split the corpus, and we have here the list of words. We will do the same thing for the second comment, the corpus 2, and we will create a list of words too. Here we have. Then we're gonna get the unique words in both corpus. So we will set the union between the two sets. So we want everything that are in both sets, but not repeated. So we want the unique words in both comments. Here we have. Then we're going to create a dictionary to count the occurrence of the unique words in both corpus. This is the part, like the count of the words, it's bag of words. So that's why I always say that there are many different ways to do the exactly same thing, especially if you're implementing from scratch. You can do bag of words in a different way. You can do TF-IDF in a different way. And that's the beauty of coding. So don't feel like pressure to use the exactly same tools that I'm showing here. But this is a good guide and it's proved to work. So if you are not in the mood to look for other alternatives, you can just use this one and it will work. Or you can just use the package that it's very much more usable, and we're gonna see it later. So here, to create this dictionary, we'll see like number of words 1, it's a dictionary with the unique words and 0. For word in the list of words 1, we will count the words as plus, we're gonna increase the counting like +1 if that word is in the list. So we will parse through all the words in the list of words 1, and we're gonna count them. Then the number of words 2, it's the exactly same thing for the second comment, so the second list of words. The function to calculate the term frequency is a dictionary. We're gonna create a dictionary that we're gonna count the words length, list of the words. So we want all, what is the sum, like the count of all the words in the list. And for word, count in word dictionary items. So for each word, we're gonna count how many times they appear in the word dictionary. So here we have 2 dictionaries, and we're gonna calculate the TF for both comments. And we're gonna compute the TF dictionary for them. And that's just the term frequency. So number of words 1 is the word dictionary that we created here. And the list of words is just, we created here. The num words 1 we created here. And the list of words we create back there. So in that way, it will compute the term frequency of the words. Like we have here, beautiful, that's the term frequency. That is 0, on 0, enjoy 0. So those are the term frequency. For the same thing for the second comment, and we're gonna call it TF2. And later we're gonna create a function to calculate the IDF. So to define the IDF, we import math so we can use the length of the document. And IDF of the dictionary is, we're gonna get the keys from the dictionary. And for each document in the documents that we're gonna parse, we will check if that word is in there. So what we are doing in the IDF function, it's exactly like counting the number of words that appear in those documents. How many times that specific word appear in all the documents. You have like the log of the, right here, log of n, that it's the total number of documents, divided by the value in the dictionaries that we are creating, where we have the number of times that that word appeared in all the documents, like how many documents that word appeared. So that's what we are calculating here. Here we have the IDFs. So we're gonna compute the IDF for the number of words 1 and number words 2, the 2 sets. And we have here the IDFs for all of them. Then we have a function to calculate the TF-IDF that is just like the value like multiplied by IDFs of the word. So the TF-IDF of that specific word will be the value that we calculate in the IDF, in the TF, versus the IDF. And here we have the TF-IDF of the first set and then the second set. And we're gonna include them in a data frame so we can see the vectors. Beautiful will have a vector with two dimensions, and the first document will have a 60 dimension because 60 are the number of unique words in both documents. You see here that's a little bit different. We said like the words will have a row and the columns will have the document. That doesn't matter. Like here we have the columns for the words and the rows for the documents. Usually you can define that, but it's fine either way. You just have to remember that the word vector will be related to this column because we have the columns of the words. And the document vector will be related to the row because we have the document in the row. Okay, so this all we took to do the TF-IDF from scratch, like manually, kind of. And now we're gonna use the TF-IDF Vectorizer. And here we will call the TF-IDF Vectorizer. And we're gonna create vectors after we fit transform in both corpus. We get the feature names in get feature names, and dense vectors to dense list, dense to list. That's just so we can create a data frame. So that's why we do those two transactions here, because we want to be able to see them in the data frame. Okay, so here we have again the words and the documents. We see that here we have 58 columns. That means that we have 58 words, and here we had 60. And that's an important thing that we have to go over, because when we use a specific package, we don't know exactly what it's inside there. And that's why it's important to go over the documentation. And we will check here the feature extraction text TF-IDF Vectorizer. I want to show you what exactly are the parameters that we have for this function. So here we have, and that's a very good documentation that we have for this this package in Python. They usually have this, like the parameters and the attributes and the methods included, and examples later on. So that's very important. If you have no idea how to use, you have to come back here and check. So here the first parameter is the input. It's the file name or the variable that contains the documents that we want to vectorizer. Then we have encoding, decode error, strip accents, lowercase. So here we have a preprocess that we already did, but you can see here like the default, it's none. But if you didn't do it and you want to include the tokenize in the lowercase, you can do that. Also here, this is the analyzer. It's an n-gram. We're going to see this later because Word2Vec use that. So we can talk about it later. Here you can also include the stop words. So if you want to remove the stop words from your vector and you didn't do the pre-process, you can just use this parameter here. Token as a pattern, and here regular expressions, it will tokenize the word. So here it's important. That's the part that we have the difference between the one that we implemented manually and this toolkit. That's because here it only selects the tokens with 2 or more alphanumeric characters. So everything with 0, of course, but with 1, like A, I, will not appear in our vocabulary. And that's why we have 2 words of difference between the one that we did implemented manually and the one using the TF-IDF Vectorizer. This is n-gram range. We're gonna talk about it later. Max DF, it's the document frequency. If you wanna take it out, document frequency, a specific value of document frequency, you can take it out. The same for the minimum. Max features, if you wanna consider just the top 10 features to build your vocabulary instead of all of them, you can also use this. Vocabulary, you can find here a mapping with the keys are the terms and the values are the index. If you already have a feature matrix, or if you want to include this feature matrix in your output, binary, D-type, norm, and everything else. So that's why it's important for us to go ahead and check the documentation when we are implementing something that we are not doing from scratch. So that way we know exactly what the package is using to calculate, what parameters it's using to calculate. So here they have an example and also the method. So each method has its own example here and what is exactly what it does. So this is all you can do using the TF-IDF Vectorizer. So I highly recommend you to go over the documentations of, especially this is scikit-learn. It's very useful and it contains a lot of information, and every time you use a package you need to know what is inside there. And that's why we have here. And when you visualize the vocabulary, you will see the I and A are not here. So that's why TF-IDF Vectorizer only consider words that have more than 2 characters. So that's it for today. I hope you can implement that for our homework. And if you have any doubts or any questions about it, just let me know. You can also go over the resource that we have available. But if you need any help and for any reason you can't implement that, just let me know. See you next time. Bye-bye.